Okay, 3-2 functions. This is the online notes in WSQ. So today I can determine whether a relation is a function and find function values. We are doing standards FIF1 and FIF2. So functions, when an element of a domain, which means the x value, is paired with only one value of the range, that's the y value. So a way of writing an equation so that y equals f of x. This is important. So this means you can exchange, when we have y in an equation, you can exchange that with f of x. A function is a relationship between input and output. So I put something in the equation or the function and I get something out. In a function, there is exactly one output for each input. So that means if I put in an x, I get a y out. I can't have two y's going to an x. So as you can see how this mapping in this graph is, every x value has a specific y value. The way we can test for this is the vertical line test. And with this, what we are looking for, the blue is the graph, and the green is our line that we draw, the vertical line. This only touches the graph once at the highlighted point. That means it is a function. So if we draw a vertical line anywhere on this graph, it only touches once. This means it is a function. So here, it touches it twice. It is not a function. So it can only touch a graph once. So here we're going to practice. We're going to determine if the relations are functions. So over here, where I have the mapping, I have the domain and the range, so this is the x, this is the y, and every x value goes to a specific y value. Even though this line, these go to the same y value, that's okay. You can't go the other way, like the y value can't go to the same x value. So this is a function. So here, this is x, this is y. X repeats. You have a 2 here and a 2 here. That cannot happen. So this is not a function. And down here, we have a relationship of ordered pairs. Your x is the first value, your y is the second value. And it looks like I have an x repeating. So this as well would be not a function. So a y can repeat and x cannot. So let's try it. Long jump. 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as follows. Team 1 has 20.6, Team 2, 21.5, Team 3, 20.9, Team 4, 19.4, Team 5, 20.2. Make a table, determine the range and domain, and determine whether the relationship is a function. So let me get some colors up here instead of... So when we make a table, we're going to have our x and our y values. Our x values are going to be our independent values, so we would just write these teams. So team 1, and then our y value is what would go with that, 20.6. Team 2, 21.5. Team 3, 20.9. Team 4, 19.4. and team 5, 20.2. So, and then it says write the range and domain. So domain, once again, are my x values. So I'm going to write that 1, 2, 3, 4, and 5. We would actually put that in function notation or in set notation. So those are just the squiggly lines around it. And the range are my y values. So 20.6, 21.5, 20.9. You should probably put these in order, but you don't really have to right now. And determine whether the relation is a function. So do any of the x values repeat? No. So this is a function. Okay, determine whether 6x plus 2y equals 14 is a function. So the way we're going to start this, we're going to start by graphing. So we're going to go to Desmos and graph. Okay, so you're going to put this equation in just as it's shown. So you're just going to put in 6x plus 2y equals 14. And you're going to see a graph. So that looks something like that. Now I'm going to do my vertical line test. And I'm just going to be able to draw vertical lines anywhere on this graph. And it only seems to hit the graph once with each line. So that means, yes, it is a function. Okay, so we need to look at function notation. Remember, I said y equals f of x. So when I have something like this first equation, so I have the y here. So what changed in between these two equations? I changed the y to an f of x. Second equation over here, I have a y. All I did to change it to function notation is change it to f of x. For f of x equals negative 2x plus 9, find each value. So it says, people get confused on this, but there's really no reason. So all we're doing is taking this negative 6 and plugging it in for the x. See how it went in for the x here? That means I need to put it in for the x there. So f of negative 6, I'm going to substitute negative 2 times negative 6 plus 9. And that's it. I'm just going to solve. So negative 2 times negative 6 is 12 plus 9 equals 21. So f of negative 6 equals 21. Now on the second one, I have a lot more going on. So the first thing I need to do is find f of 4. And then when I'm all done, I'm going to add this 3. So let's start with f of 4. So I just take out the x and put the 4 in. So that's negative 8 plus 9. And then that's 1. So f of 4 equals 1. So now I need to find f of 4 plus 3. So I am going to take what I got here and add 3. So I'm just going to substitute again. So f of 4 equals 1. I'm going to add 3, and that equals 4. So here I have two functions going on. So I need to find these separately, and then I'm going to subtract them. So I'm going to do f of 5 first. Negative 2 times 5 plus 9. So that's negative 10 plus 9. So negative 1 equals f of 5. So now I'm going to separately do f of 1. Negative 2 times 1 equals 9. That's negative 2 plus 9 is 7 equals f of 1. Now that I have these two answers, what's it say to do? I'm going to subtract them. So I have negative 1 minus 7, so that is negative 8. So this equals negative 8. Mason works at the movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes for each hour he's worked. So we're going to evaluate for hours. So let's say he works 10 hours. So that means I'm going to find g of 10. So that means that's 9.25 times 10. Which is 92.5. So if he works 10 hours, he makes $92.5. What if he works 40 hours? So let's do G of 40. So that's 9.25 times 40. I'm going to have to do that in my calculator because I don't know that off the top of my head. It's $370. So he makes, for 40 hours, $370. Okay, great. Make sure to fill out the WSQ.